For the longest time, when scientists went looking for consciousness in the brain, they were basically hunting for a mirror, some set of neurons that perfectly reflects what we see and feel. But what if that mirror is cracked? Or what if it was never even there to begin with? In this explainer, we're going to dive into a really powerful argument that might just change how we think about the mind itself.
So here's how we're going to break it down. First, we'll get a handle on this consciousness mirror idea that's driven so much research. Then we'll see exactly where the cracks in that mirror start to show. After that, we're going to explore a totally different way of thinking about perception, see why context is everything, and finally, look at how this new perspective might actually solve one of the biggest puzzles in neuroscience.
All right, so let's get into it. This whole thing kicks off with a really simple, kind of intuitive idea that has shaped brain research for decades. It's this assumption that to understand our experience, all we have to do is find its perfect reflection in our neurons. And it all really starts with one basic question.
I mean, that feels like a pretty straightforward question, doesn't it? It seems like common sense. If you're seeing something, that image has to be somewhere in your head. And that very natural assumption leads scientists to a major idea about how our brain creates reality.
And this is the big idea. It's called the matching content doctrine. The core of it is that for anything you experience, seeing a red apple, hearing a song, there's a group of neurons firing in a way that is a perfect one-to-one copy of that experience. It's not just that the brain activity is related to what you see. The idea is that it is what you see, just written in the language of neurons.
So, this gives scientists a really clear mission. Find the neural correlate of consciousness, or the NCC. The hunt is on for that perfect mirror, that spot in the brain where the neural activity has the exact same content as our experience. Find that, the thinking goes, and you found the physical basis of consciousness.
But here is where things get really interesting, because it turns out the very kind of experiment that was supposed to prove this mirror theory, well, it's actually the thing that reveals the first subtle but absolutely critical crack in the whole idea.
These experiments are super clever. They're called binocular rivalry experiments. Imagine I show a picture of a butterfly to your left eye, and at the same time, a picture of a sunburst to your right eye. Now, your brain doesn't just mush them together. Instead, what you consciously see flips back and forth, first the butterfly, then the sunburst, even though the images hitting your eyes haven't changed at all.
So when they did this with monkeys, they found something amazing. The brain activity in a key part of the visual system didn't track the physical images hitting the retina, it tracked what the monkey was actually perceiving. When the monkey saw the butterfly neurons fired. When it saw the sunburst neurons fired. On the surface, this seems like a slam dunk for the matching content doctrine. Case closed, right?
Well, not so fast. This right here is the absolute key question. The experiment shows a strong correlation, for sure. The brain activity goes along with the experience. But is that the same thing as a perfect match? Is going along with the same as being identical to? Believe me, that distinction changes everything.
And this illustrates the difference perfectly. A match means the brain pattern and the experience are identical copies of each other. But agreement is something different. Think about it like this: a detailed photograph of a forest and a poem about that same forest. They're both about the forest, they agree on the content, but they are obviously not the same thing. The binocular rivalry experiments prove agreement, but they offer zero evidence for a perfect identical match.
And that brings us to the real heart of the argument. This is a fundamental problem with the whole mirror theory, and it's not about interpreting some fancy experiment. It's about the very structure of your own experience, right now.
Just look around the room. You never see an object just floating in a void. You see a figure against a ground. Your computer monitor stands out against the wall. The words on the screen stand out against the white background. This figure-ground structure isn't an optional extra. It's the basic, inseparable fabric of all perception.
But you see, the matching content doctrine is inherently atomistic. It thinks about perception like a bag of Legos. It assumes there's a neuron brick for blue, another one for curved line, and another for motion, and that your brain just snaps them all together to build your experience. But perception isn't a bag of Legos. A much, much better analogy shows why this whole atom-by-atom approach just fails. And that analogy is the difference between a bag of ingredients and a finished baked cake.
Okay, think about it. Individual neurons firing, those are the raw ingredients, the flour, the sugar, the eggs. But your conscious experience of seeing a butterfly against the sky, that's the fully baked cake.
You can do a chemical analysis of the cake and find traces of the ingredients, sure, but you cannot point to a crumb of the cake and say, this part right here is the flour. It's been transformed into something totally new, cake. In the same way, perception is a new, holistic whole. You can't find a single neuron firing that is the experience because the whole is fundamentally different from the sum of its parts.
And if that wasn't a big enough problem for the mirror theory, it gets even deeper. Because it turns out those neural ingredients we were just talking about, they aren't even stable, isolated things to begin with.
So, scientists talk about a neuron's receptive field. That's basically the specific thing out in the world that makes it fire, like a vertical line or the color red. The mirror theory kind of assumes this is a fixed property, like a little detector. But the evidence shows it's not fixed at all. What a neuron likes is constantly changing based on the wider context.
So the very same neuron might respond differently depending on where you're directing your attention, the posture of your body, or the specific task you're trying to do. In other words, there's really no such thing as an isolated neural atom. Its meaning is defined by its relationship to everything else that's going on.
As the scientist Francisco Varela put it, you simply cannot know what a neuron is for without knowing what the entire organism is doing. This completely shatters the idea of finding a neat, self-contained neural atom that could perfectly match a piece of your experience.
All of this leads us to a really stunning final implication, one that challenges a puzzle so famous in neuroscience, it's simply known as the binding problem.
So the binding problem is this. Your brain processes color, shape, and motion in different areas. So how does it bind or glue them all together to create your single, unified experience of a red ball rolling across the floor? For decades, scientists have been searching for the brain's superglue.
But after everything we've just talked about, the fact that perception is holistic, not built from little pieces, we have to ask a radical question. What if we've been trying to solve a problem that doesn't actually exist?
And here's the final insight. The binding problem only makes sense if you believe experience is built from separate neural atoms that need to be glued together. But if perception is holistic from the very start, if it's always the whole cake and not a bag of ingredients, then there were never any separate pieces to bind in the first place. The problem just dissolves.
So by rejecting this simple idea of a consciousness mirror, we're left with a much deeper, more profound picture. It suggests that consciousness isn't a snapshot in the brain, but maybe it's an active process of engagement with the world. It means the search isn't for a static object, but for a dynamic relationship. And while that's a much harder scientific challenge, it's also a whole lot more exciting.